The Aurora Borealis and Aurora Australis, more commonly known as the Northern Lights and the Southern Lights, are events of such breathtaking wonder that their displays were in times past unmistakably seen as the act of a mythological god or goddess, an act beyond all reasoning or science. Times change, and now we can explain them, but many still do not understand what really makes an aurora work. The Earth has a magnetic field that is the result of a magnet in the center of the Earth, which is so big that its range is that of the entire planet, extending just beyond the atmosphere. Auroras are caused by solar storms which collide with the Earth's magnetic field. These solar storms are caused by a solar wind that the sun is constantly blowing away from it. This solar wind carries particles released from the sun's surface towards the Earth. When the particles that are brought with the solar wind collide with the Earth's magnetic field, they are stopped. These particles then have to travel along the magnetic field towards the nearest pole on the Earth, north or south, where there is an opening in the magnetic field. As the particles enter the hole, they will eventually collide with an atom in the Earth's atmosphere, causing the atom to emit light. This continually happens to many atoms in the atmosphere, and this light they give off becomes visible in the sky from Earth, what we call an aurora. This would make it seem like auroras are only visible over either of the poles, but this is not always the case. Auroras can grow bigger and spread farther down the Earth, but certain factors have to come into play for that to happen. A research study examined aurora sightings in the Canary Islands from 1770 through 2010 to determine the factors that play into aurora appearances. The Canary Islands were chosen for their relatively low latitude and isolation. Low latitude was important for this study because the distance from the North Pole means that the factors that play into an aurora appearance need to be especially apparent for the aurora to be visible. The study used a sample of 9 auroras, and the aurora appearances prior to the 20th century had to be verified in more than one newspaper, research study, or other publication to ensure a genuine aurora appearance and not a fabrication or mistake. The study then compared each sighting with 3 different factors that were hypothesized to have contributed to the appearance of the auroras. The first factor is the sun itself. The sun has its own rotational cycle, which is 11 years and is marked by both a solar maximum and minimum. During solar minimum, the sun is less active, and during solar maximum, the sun is more active. What this means is that the solar wind that is constantly blowing away from the sun is less powerful during a solar minimum and more powerful during a solar maximum. The study looked at solar rotational cycle charts and found that during the aurora appearances on the Canary Islands, the sun was always closest to a solar maximum. The second factor is a measure of how strong the solar storms are that are colliding with the Earth's magnetic field. This is basically a continuation of the first factor, since a solar maximum results in a stronger solar wind, then the storms colliding with the Earth are almost certainly going to be more powerful. The study looked at an index that is a measure of solar storm activity on the Earth's atmosphere and found that the aurora appearances always coincided with solar storms of more power than the average solar storm. The third factor is the geomagnetic latitude, which is similar to standard latitude except with respect to the shifting positions of the magnetic poles instead of the standard north and south poles. The magnetic poles are different from the standard poles in that they move as a result of the Earth's rotation, whereas the standard poles are stationary and only mark the top and bottom of the world. The study found that the particles from the sun that enter a hole in the Earth's magnetic field are right on top of one of the geomagnetic poles. Because of this, auroras are more likely to be visible wherever the magnetic poles happen to be. So whenever the Canary Islands are closer to the magnetic poles, this is more likely to be an aurora appearance. Auroras truly are an amazing sight and one of the great wonders of our planet. Armed with a deeper understanding of how an aurora works, these miracles will never become dull and can continue to take our breath away.